Greetings everyone. We are the students of Sri Vishnu Engineering College for Women. Today this video is about types of errors and exception handling. This video is under the guidance of Dr. M. Prasad sir, PhD, Associate Professor, Department of CSC, Bhimavaram, and it is presented by Vaishnavi, Ushashwini and Sriza. First of all, what are errors? What are errors in Python? In Python, errors are known as exceptions. Exceptions are raised when there is an error or exceptional condition that occurs during the execution of a program. These exceptions interrupt the normal flow of the program and can be caught handled to prevent the program from crashing. There are some common errors in Python, along with a brief explanation of each. First of all, the first error is syntax errors. Every programming language has its own syntax and rules, and Python also has its own rules. And the first one is syntax error. This error occurs when the syntax of the code violates the language grammar rules. It usually indicates a typographical or structural mistake, such as missing parentheses, invalid operators, or incorrect indentation. Okay, here in this program example code, after the if statement semicolon is not there, so it shows the syntax error. And the next type of error is name error. This error occurs when a local or global name is not found in the current namespace. It is typically raised when you try to access a variable or function that has not been defined or is not in the scope where it is being referenced. Means here count is not declared before, so it shows a name error. And the third type of the error is type error. This error occurs when an operation or function is applied to an object of an inappropriate type. For example, trying to perform arithmetic on incompatible data types, passing the wrong number of arguments to a function, or calling a method on an object that does not support it. See here, x is of int data type, whereas y is a type of string data type. The result is x plus y. It shows the type error because the two x and y are both of different data types. If we want to combine each other, either in string data type, they concatenate each other in the whereas in the type of integers, they add up each other. So it shows a type error. And the next type of data type is index error. Indexing is a very important concept in case of strings or lists or tuples, etc. This error occurs when you try to access an index that is out of range in a sequence, such as list or string, etc. Accessing can be possible by indexing only. It means you are trying to access an element that does not exist at the specified index. Error occurs when you try to access an index that is out of range in a sequence, such as list or string. It means you are trying to access an element that does not exist at the specified index. That means if we take the numbers as a list 1, 2, 3, 4, 5, the indexing starts from 0 to 4. That is 0 to length of the string minus 1. Here we want to access the 10th element of the list, but we had only 5 elements. So it shows an index error which is out of range. And the next type of error is value error. This error occurs when a function receives an argument of a correct type but an inappropriate value. It typically arises when a function expects a certain range of values and the argument falls outside that range. See here in the example program, num equal to, we take the number, but we want to make the result as int num of 5. Then it shows a value error that it shows an invalid literal for int data type. So it shows an value error. And the next type of error is import error. Python has so many import functions, packages, modules, etc. This plays a very key role in the part of Python programming. This error occurs when an imported module, package, or name cannot be found or accessed. So there are so many built-in modules are there in Python. But if any module is not existed before, then it shows an import error. It typically happens when you attempt to import a module that does not exist or is not installed correctly. It can also occur if you try to import a name from a module that does not define that name. See here, we want to import a non-existent function which is not there in the math module. So it shows an import error. And the next type of error is indentation error. As we already discussed, every programming language has its own syntax rules and grammar rules. Then indentation also is very important in case of the Python language. For to start a new block of statements, indentation takes a major role. This error is raised when there is an issue with the indentation of your Python code. Python relies on indentation to define the structure and blocks of a code. An indentation error occurs when the indentation is incorrect, such as mixing tabs, spaces are not aligning code properly within a block. So here we are taking the x equal to 7. If x equal to 7, print true. After the writing the if statement, if we want to show to as a new block, but here it is not there, so it shows an indentation error.
And the next error is key error. This error occurs when you try to access a key that doesn't actually exist in the given dictionary, list, or tuple, etc. It is raised when a dictionary key or a list member is not found during a lookup operation. Actually, if a key or a value doesn't exist, this key error exhibits. In the below code, we are trying to access a key grape which is not actually present in the given dictionary. So key error occurs. And the next type of error is logical error. A logical error generally doesn't exhibit in the output, but it is generally visible. A logical error refers to an error in the logic or reasoning of a program. It occurs when the program's code is syntactically correct, but it doesn't produce any desired output due to wrong logic. These errors often require debugging and careful review of the program's logic to identify and fix them. In the below code, x equal to 5 and y equal to 3, we are trying to swap the numbers, but the logic is incorrect. Actual logic can be in the other method like x comma y equal to y comma x, but this logic is incorrect. So in the output, we can see that the values are not swapped. So this can be seen in the logic error. And the next type of error is IO error. This error occurs when an input or output operation fails. It usually indicates an issue with reading from or writing to files or other input or output devices. Here we are trying to exist a non-existing file. So in the output, we can see that an error occurred while reading the file, which is not exist. So IO error occurs. And the next error is attribute error. This error occurs when an attribute reference or assignment fails. It is raised when you try to access or set an attribute on an object that doesn't have the attribute. In the below code, x equal to 5, and we are trying to print the uppercase of the number. Actually, for alphabets, we can print the uppercase or lowercase, but for digits, it's not possible. So int object has no attribute upper. So it occurs attribute error. And the next type of error is arithmetic error. Arithmetic error is the base class for all numeric errors in the Python. It may include errors such as zero division error, overflow error, floating point error, etc. It is rarely raised directly, but it is often used to catch and handle any arithmetic related exceptions. In the below code, a equal to 10, b equal to 0, and we are trying to divide a by b. As 10 cannot be divided by 0, it raises an error, which is zero division error. As we said, zero division error comes under arithmetic error. It raises an arithmetic error. And the next type of error is zero division error. As we have seen in the arithmetic error, zero division error is a type of arithmetic error. This type of error occurs when we try to divide any number by 0. And the next topic is what is exception handling. What is exception? An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program's instructions. In general, when a Python script encounters a situation that it cannot cope with, it raises an exception. An exception is a Python object that represents an error. When a Python script raises an exception, it must either handle the exception immediately, otherwise it terminates and quits. In this example, a generic except block is used to catch any exception that might occur. It provides a generic error message without specifying the specific type of the exception. As shown in the below figure, in try block, we have to enter a number and result equals to 10 by x. If we print the result in except block, an error occurred. This is an example for generic error message. This example extends the previous one by adding an additional except zero division error block. It handles the case when the user enters 0 as input, which would cause a zero division error during the division operator. As shown in above slides, zero division error. In this example, in try block, we have to enter a number, result equals to 10 by x. When we print the result in except block, we have to print invalid input, please enter a valid input number. In zero division, in except block of zero division error, we can print can't divide by 0. When we enter a number, it can display can't divide by 0. And we have to enter another number, 1, result equals to 10. Here, the else block is included which executes if no exceptions occur. In this case, it prints the result of the division. Exception handling with else block. In try block, we have to enter a number and we have to print the result in except block, and in zero division error can't divide by 0. And in else block, we have to print the result. When we enter a number 1, result equal to 0. In this example, the finally block is used to specify code that should be executed regardless of whether an exception occurred or not. In this case, it simply prints execution complete after the try except else blocks. These examples illustrate different ways to handle exceptions in Python. By using try except blocks, you can gracefully handle errors and exceptions, ensuring your program handles unexpected situations without crashing, as shown in the below code. In Python, you can define your own custom exception types by creating a new class that inherits from the base exception class or any other existing exception class. User-defined exceptions allow you to handle specific exceptional conditions in your code. Here is an example that demonstrates how to define and use a user-defined exception, as shown in the below code. Thank you.